The overall purpose of the nervous system is to control and communicate to other organs in the body, such as muscles and bone. The nervous system can be thought of as an anatomical system. It's not really all that useful. And in doing so, we break the nervous system up into two parts. We have the central nervous system, and then we have the peripheral nervous system. The CNS, or central nervous system, is made up of only the brain and the spinal cord. That's it. If you're in one of these two places, you're in the central nervous system. The peripheral nervous system has a great definition that's called everything else. It's basically anything else that is a cranial nerve, which are nerves that come out of the skull. Don't mean to be a jerk, but sometimes I like to state the obvious just to be sure. And then you also have pairs of spinal nerves. When I say everything else, what I do mean is like the nerves in your somatic tissues. So anything that arises from a cranial nerve or anything that arises from a spinal nerve. A nerve itself, like the sciatic nerve in your leg or the ulnar nerve that runs along your quote funny bone, a nerve in itself is a collection of neurons. And a nerve, as a collection of neurons, it exhibits the purpose of having an action potential over long distances to control organs in the body. As pictured here, this is a picture of the brachial plexus, which means that it's part of the upper arm, and the word plexus just means network. So this is a network of nerves that are in the upper arm, kind of like shoulder neckish. Your ulnar nerve, or the nerve that you hit when you hit your funny bone, it's a collection of neurons arising from this upper arm network of nerves that have left the spinal cord in the lower neck and upper back region. Pictured here on the right is an inferior view of the brain. So we're looking at like underneath the brain, kind of like looking up at it. And this wrinkly part here, that's the cerebellum, or the little brain that's on the back posterior. All of these little yellow spaghetti stringy things here, these are the 12 pairs of cranial nerves that arise from the brain stem and other inferior structures from the brain. Each one of these nerves pierces the skull at some point and has its own foramen or hole associated with it. To be perfectly honest, the nervous system can't really be thought of as an anatomical system. It's so useless to think of it as the CNS and PNS. And that's because its function is so varied. No part of the nervous system works alone, and there can be thousands of neurons just helping you scratch your head right now. Do it. Scratch your head. I can make you do what I say. I'm kidding. Therefore, more often in this class, we will think of the nervous system as a functional system. Its organization is about function, not about anatomy. Let's look at some of the terminology on this slide, because it's terminology that I want to hear you use, and it's terminology that I will consistently use throughout the next 4 or 5 chapters of the nervous system. As you may have guessed, over here on the right is all sensory information, which is information that is incoming into the brain. And another word that we can apply to incoming information is this word afferent. This word afferent just means into the brain, into the central nervous system. So a mosquito, it lands on your arm, and you have a pressure sensor that senses the touch of the mosquito. And that pressure sensor sends an action potential or an electrical current to your brain, alerting you that a mosquito is about to suck your blood. Here's a little mosquito, right? And here's an action potential that goes up into your brain and says, mosquito, mosquito, mosquito. Those sensory neurons and nerves would also be thought of as somatic, because they're part of your skin, bone, and muscle, not part of your squishy organs. So somatic is really what we cover in this class, and viscera is kind of what we cover next semester. Right now, you have chemosensors in your stomach that are sending signals to other parts of your digestive system to coordinate its movements and digestive activity. Those sensors are sensory, but they're also visceral because they're in your guts. Over on the other side of this picture is the same setup that you have, but this is for motor output in neurons and nerves, right? So this would be efferent action potentials. The word efferent just means out of, and you may have an action potential coming down, going out, and all the way down to the toe of your foot, where it causes you to have a contraction. We have talked about something called the neuromuscular junction, and that is a somatic output of an action potential, right? So the neuromuscular junction, if it ends in the neuromuscular junction, it is somatic motor. Right now, there are regions of your brainstem that are allowed to have input on your breathing rate and your heart rate. And these neurons are leaving those centers, innervating your heart and lungs, and those would be visceral motor neurons. Most of them are involuntary.